Good evening, everyone. Thank you so much for joining us. Welcome to our webinar on building a net zero smart home with Lindal. Thank you so much again for joining us. This is our first ever webinar on this very important and timely topic. My name is Christina Lindal, and I am the president of Lindal Cedar Homes and a very proud member of the third generation of leadership. I am delighted to have with us today our guest presenter, Laurie Pitman. Laurie gave her first talk on building her net zero Lindal home as a keynote speaker at our annual conference earlier this year, and we were so impressed by the depth of her knowledge and the thoughtfulness of her presentation that we asked her if she would do another presentation for a wider audience. And our two are very big delight. She happily agreed. Her program this evening is about 30 or 40 minutes, and we'll have a short Q&A session as well. So if you do have any questions, we do have a questions box there. Please feel free to type those in, and I'll ask them to Laurie at the end. But before we get into the main body of this presentation, I'd like to give you a little bit of an introduction on who we are and what we do, if you're not familiar with Lindal. So Lindal is North America's leading manufacturer of high-end post and beam homes. We design these homes collaboratively with our clients using our Lindal Elements modern grid system for maximum efficiency, beauty, flexibility, and scalability. For over 75 years, we have been delivering premium packages containing all the exterior materials required to build the homes to our clients' sites throughout the US, Canada, and internationally. The homes are constructed on site by local builders. We are headquartered in Seattle, Washington, where I am presenting live. Laurie is also live here with me, and she's just about an hour, or I should say a ferry ride away, no, not very far at all. We operate through an international network of Lindal representatives and distributors who establish relationships with our clients at the local level and help guide them through the entire process, from first site visit to move-in day. Time and time again, clients have told us that this personal relationship with our local representative is one of the key reasons they choose to work with Lindal on their dream home. Of course, many other reasons include the premium quality of materials that you can't find locally, our 75 years of experience, our timeless beauty of our home designs, and of course, a lifetime structural warranty. We do have 3 other webinars that we put on either monthly or bi-monthly, also live. They include our start to finish look at our modern home designs and what it looks like to work with Lindal. We also talk about our collaborative custom home design process with OM Studio. And we also have another series of homes that we have a very special webinar that is all about our Usonian designs inspired by Frank Lloyd Wright and licensed by his foundation. So if you'd like to join us for any of those webinars, we encourage you to do so. They're all free, and you can register for them on our website, lindal.com/events. I'll put up this screen again at the end in case you're interested. So without further ado, I would like to introduce our very special guest speaker, Laurie Pitman. Laurie Pitman is a polymath with many interests and multiple careers. Originally trained as a classical pianist, she worked as a professional pilot in the 1980s. She earned her master's degree in library science and also studied for her PhD in Ottoman literature. In 1990, she co-founded a highly successful software company in San Francisco and built her first net zero house in the Berkeley Hills and lived there for many years. She just relocated to Washington State in 2020. She's an avid gardener and lives in her Lindal home on a 20-acre property with her adorably cute border collie, Emma, and of course, many other wildlife visitors as well. So welcome, Laurie, and thank you so much for joining us. I will pass over the presentation to you and let you take it away.
Okay. Today, I'm very happy to be doing this. I'm going to give you a crash course on building a net zero smart home and show you why Lindal makes that easy. I finished my net zero Lindal home in rural Kitsap County just last year. It's set on 10 acres of evergreens and trees. When I bought the property in 2020, it was overrun with blackberry vines and salal because the previous owners had logged the biggest cedars in 2008. I miss the big trees, but the upside is that it left a pretty good sized clearing with direct southern exposure, which is key for solar. It took about 15 months to build the house from foundation to final inspection. This is the second net zero smart home I built. I built my first net zero home in Oakland from 2013 to 2015. That's the bottom photo. And things have changed a lot since then, mostly for the better. Let's start today by making sure we're clear about what we mean by the term net zero. A net zero home is almost always all electric and almost always includes solar. There were 53 panels on the roof of the home in Oakland, and I have 38 panels on my new Lindal home, which, by the way, produce exactly the same amount of energy as those 53 panels did in Oakland. But building net zero is not just about adding solar. For instance, when I built the house in Oakland, I installed a 16,000-gallon water tank under the driveway to collect rainwater from the roof, since in California, water is a scarce resource. Net zero really means taking a look at where you live and how you live and finding renewable sources for all of the resources that you need. Maybe we should also define what net zero isn't. Solar on the roof is a good start, but having a diesel backup generator or a gas stove or a fireplace, that means you're not net zero. Net zero means that all of the energy the house needs is supplied by renewable, non-polluting, non-carbon-based sources like solar or wind. When I tell people that my home is net zero, they'll say, "Oh, well, you're off the grid then." Being off the grid doesn't equate to net zero. My home is not technically off the grid. I trade power with Puget Sound Electric. Although when the power goes off, yeah, I'm off the grid, but I have battery backup that keeps my net zero home comfortable. On the other hand, you can see in the bottom photo that these cabins, which are probably off the grid, are certainly not net zero. They have wood burning fireplaces. Building net zero isn't hard or complicated if you plan for the details from the beginning. The drawing here is of my IKEA kitchen layout that I gave to my architect, Michael Harris, while he was still working on the initial design because I wanted to make sure we had room for it in my new home. Michael will tell you that I knew where every rug, every piece of art, every table, every chair was going. Particularly if you're building small or downsizing, you need to plan ahead. No, that enormous sectional probably won't fit in your living room. Can you live without a dining room? You need to think about these things while you're designing the house, not while you're building it. It's important to examine what you want in a home because you're going to be living in it for a long time. It can be the most efficient home in the world, but it still has to suit you. I knew that I wanted to build a home that fit in the Pacific Northwest woods, which is a big reason why I chose Lindal. I think Lindal homes personified the beauty of the Pacific Northwest. They fit the landscape. As Frank Lloyd Wright said, no house should ever be on a hill or on anything. It should be of the hill, belonging to it. Hill and house should live together, each the happier for the other. As you consider where your net zero home will live, be practical about the location. Is there enough solar potential? I looked at about 60 properties in Kitsap County before I found the one I eventually bought. There were some that were tempting, but lacked enough southern exposure for solar. Also consider what's the neighborhood power personality. I lived in an RV on my property for 18 months while I was building. I discovered right away that my neighborhood suffers frequent power outages, so I planned ahead and I installed battery backup power. You also need to think about how you'll live there. For me, I just turned 70. I wanted a house where I could age in place. So I did two things. I built a single level home with accessible entrances, and I built what's shown on the plans as the workshop, which is a little guest suite on the far side of the garage, a studio apartment that eventually may house someone who cares for me in my old age. The other thing I really thought about was landscaping. I wanted something easy to maintain and mostly permeable surfaces. You can see in the photos that my front lawns aren't lawns at all. There is no grass. I have mulched plantings around the big cedar in the circle, but the rest of it is a wildflower garden that only needs to be weed whacked once a year. Next to the house, I planted Japanese forest grass and bayberry, but mostly it's a rock garden with plenty of underground drainage. We had a flooding problem during construction, and I solved it by installing drains under the rocks. Here are the plans. Inside the house, I've got 2 bedrooms and 2 baths and a big open living area between them. On the other side of the one-car garage is what we call the workshop, which I've turned into a 3rd bedroom and bath with a little kitchenette. That closet in the workshop houses the water filtration system. And that extra wide garage is because I knew we'd need room for infrastructure. This plan started as the Lindal Cedar Quick Ship. My architect Michael modified it to give me a little more room, and we reconfigured the west side of the house, shown on the left here, to fit in a laundry closet. We modified the open living area to provide room for my library and my Steinway B piano. The extra space came from pop-outs on the north and south sides of the house. One of the great things about working with Michael Harris was that he understood that although I needed a little more room in certain areas, I didn't want a big house. I just wanted a home that was appropriately sized. A bigger house takes more energy to heat and cool, and it takes longer to vacuum and clean. But even in a small home, you'll need to plan ahead for infrastructure. The photo on the upper left shows the water filtration system, which lives in a closet in the workshop. I planned that closet right where the water comes into the garage so that it would be easy to add the filtering system. The photo on the right shows the solar infrastructure housed on the west wall of the garage, 3 large LG batteries and the 3 solar edge inverters that serve the 38 panels on the roofs of the garage and the house. I also chose easy to clean concrete floors. I live in the country and I have a dog. The photo in the center shows the floor in the library while I was sealing and applying wax, which I reapply about once a year. The concrete has integral color, and a low gloss wax gives the floor a nice natural stone look. Now, if you're downsizing into your new net zero home, you'll want to make your space feel as large as possible. You do that with light colors and simple trim. Lindal helps you out by giving you high ceilings and lots of windows and their beautiful designs. Other strategies that I used in my home: very few upper cabs in the kitchen. This is the 9th kitchen that I've built, and I think I've got the perfect kitchen design now. For someone short like me, upper cabs don't make much sense, and the few that I use are lit cabs with glass fronts, which make them seem more like furniture and less like a cabinet. I also use glass doors for all the doors, both interior and exterior, except the closet doors. As you can see in the photo on the left, the glass in the interior doors has a satin finish for privacy, but it still lets light through. I also added clear story windows in the baths and in my walk-in closet. And in the bathrooms, I used very large vanity mirrors that go all the way to the countertops behind the sinks. In my bathroom, I made the pocket door between the bath and closet into a mirror, which removes the need to take up wall or floor space for a full-length floor mirror. Key to making a small home feel larger is open sightlines inside. This photo is the same view from opposite sides of my house. That openness keeps you from feeling as if the rooms are small. I also built a big patio outside the back door so that during the nice months of the year, I double my living and dining space. And I built an ADU, a little studio apartment on the other side of the garage so that my guest can visit without making either me or my guest feel cramped. Now comes my favorite topic on building a smaller home: closets. In your new net zero home, you will probably need more closet space than is currently on your house plans. In the house I built 10 years ago in Oakland, I had a large room called the house closet that held most of the things on this list. In my new Lindal home, I didn't have space for an extra room, so my architect carved some space out for a pantry and laundry closet, shown on the right, and I turned the guest room closet into an office closet, shown on the left, which houses my printer and scanner, my office supplies, as well as my sewing machine and all of my sewing gear. Michael also added a big closet in the entry. That's some of the most important space in the house. Not only does it function as a coat closet, there's also a metal rack on one end that holds all of the networking and communications equipment. This is where the cable from the Starlink satellite receiver on the roof comes into the house, and where the Starlink modem and the main house router and switch live. It's also the location of the manifold for the radiant heat piping that serves the house, which you can see in the right two photos. That cover I made attaches with strong magnets, not hinges, to give a nice clean profile. Since there are a lot of things that put out heat in this closet, I installed a vent fan. It's controlled by a temperature sensor switch and a floor level vent that I can open to allow cold air inside during the winter to help cool this space. That vent in the front hall closet is one reason why I can't classify my Lindal home as passive. Passive design, a net zero building strategy that focuses on the envelope, is big in the Nordic countries and Northern Europe. A passive house is heavily insulated and has very strict controls on the air that comes in or goes out to minimize heat loss in the winter or unwanted heat coming in during the summer. That just wouldn't work for me. I leave doors and windows open. What that cost me is about a 15% heat loss in the winter, and in warm weather, heat gain through those beautiful but uncovered double pane windows in my living room. But my door test succeeded the first time. I chose Marvin windows and Simpson exterior doors, mid-range choices, but very well insulated. According to the guy who did the blower test, Lindal homes are always tight, and in my case, the concrete floors made a difference. One thing I did do was install an outlet in the ceiling above the windows in the living room in case I ever want to add motorized window shades to cut down on summer heat from that beautiful west exposure. As I said, most net zero homes are all electric. I want to mention Hunters Point in Cortez, Florida, which is the first residential development in the United States to be certified as LEED Zero Energy. Every home in the development is net zero. Each home comes with 14 solar panels and a 12 kilowatt hour battery, and they are famous because when Hurricane Ian struck Florida in 2022, nobody in Hunters Point lost power. The developer spent about $88,000 on solar panels and efficiency upgrades for each home, which is about what I spent on batteries and panels. And the homeowner can claim 35% of that in federal tax credit, about $30,000 when they file taxes the first year after purchase. The entire community acts as a virtual power plant. They support the local grid by allowing the power company use of their stored battery power during periods of peak demand, and then the utility recharges the batteries during times of low use. There are over 500 such projects in development in the United States and Canada. These are important because they help strengthen the grid and offset peak demand that otherwise would come from carbon-based auxiliary power. So when someone asks you why you're building an all-electric home powered by solar energy, you can say it's because it's good for the environment. You can also say it's because it's saving you money. I built a 15.2 kilowatt solar system for about $40,000, for which I received a hefty initial federal tax break. At today's electricity prices, that system will be paid off in about 8 years. And after that, my electricity is nominally free. And electricity rates have increased about 25% in the last 10 years. So building an all-electric home powered by solar is both environmentally friendly and fiscally smart. Now, like everything else, you have to plan for how the house is powered. You're going to want to use the most efficient lighting and appliances that you can find. And you'll also need to think about what does not get powered when you're on battery power. I have about 75 amps of backup battery power, but that won't power my entire house. In my case, everything in the garage, all the infrastructure, is on what's called the critical loads panel. That means I'll have hot water, heat, and well water when the grid goes down. But I had to make some choices about what goes on the critical loads panel in the house. The photos here are of the two panels that power the house located in the guest room. The one on the left is the critical loads panel, which powers most of the lights in the house, the fridge, the cooktop, the smoke alarms, the fans, and, important, the plugs in the communications closet so I don't lose connectivity when the power goes out. On the main house panel is everything else, including washer and dryer, septic, oven, and dishwasher. These things are not automatically shifted to battery backup during a power outage. However, I can backfeed the main house panel through the critical loads panel if, for example, power is out for several days and I need to run the septic pump or do a load of laundry. I just have to be selective about what's turned on when I'm on battery backup. Now, one of the challenges in building an all-electric home is getting through code review. The building department sees an all-electric home as a drain on the grid. And even when you're pointing at all those solar panels that are going on the roof, their approach is to encourage people to use high-efficiency gas or propane appliances instead of electric. I hired a local efficiency expert who figured out how to get me enough points to pass the code review. Part of that entailed promising to install Energy Star rated appliances in my home. The photo here is of the hot water heater and radiant heat system on the east side of the garage, which faces the solar equipment on the west side of the garage. Just remember, all these things not only consume a lot of energy, they also take up a lot of space. There are some things that, no matter what you do, are not environmentally friendly, and one of those is concrete. If the cement industry was a country, it would be the third largest emitter of carbon dioxide in the world after the United States and China. What makes cement, which is the binding agent in concrete, so bad environmentally is its production process. First, you extract calcium carbonate from raw materials like limestone, and then you heat the powder at high temperatures in a rotating kiln. We pour about 250 million tons of concrete a year. Finding a way to make cement with a smaller carbon footprint is big business. There are beginning to be alternative concretes, and I tried to find a supplier when I was building, but there just aren't any in Kitsap County. My house uses Portland cement, and I love my concrete floors, although I do wish that they were made from one of the new eco concretes, which are getting easier to find and cheaper. Some companies use aluminum silicates produced from fly ash, alkali activated cement, which produces 95% less carbon dioxide than ordinary Portland cement. There are also some cements that are produced from crushed industrial waste. Some of those products are cheaper and last longer than traditional concrete, but they may be hard to get. And that is a really good reason to recycle your construction waste because much of it is reclaimable and reusable. Composite concrete uses additives that actually improve the concrete. It has a longer lifespan due to its increased resistance to corrosion, and better workability makes it easier to place and finish. Lower heat of hydration during the curing process reduces cracking, which protects from water damage. At the very opposite end of the spectrum from basic concrete is the technology that makes a modern home into a smart home. If you're building a smart home, I built two now, I have some advice for you. Do not choose technology that is too new. We call it not the leading edge, but the bleeding edge. When I built my home in Oakland 10 years ago, I installed 83 Wi-Fi light switches. They were just coming onto the market, really expensive, from a little Austin startup called Plum. I had the largest installation of any of their clients, and I ended up being a beta test site for them. Unfortunately, about a year later, Plum got bought by a big German consortium, and they literally disappeared overnight. No notice to their customers. The phones and email just quit working. This was about the time my light switches were beginning to fail. I ended up having to replace all 83. The second time, I did my due diligence and chose a large company that makes a lot of networking equipment. TP-Link is not very sexy, but I knew they were unlikely to get bought or go out of business, and that's important. Now, appliances, you'll want to install a magnetic induction range. I have a Bosch, and I am a convert. I don't miss my gas range at all. Magnetic induction cooking is very efficient. It's not at all like cooking on an old electric range, and it doesn't pollute your home with nitrogen dioxide and methane. My Miele dishwasher and convection oven, the refrigerator drawers, TVs are all Wi-Fi connected. I have Wi-Fi plugs for the things that aren't, so I can turn things on and off with my phone. What this means is that you're going to need good connectivity all over the house. You need to plan for wireless coverage and for having all of those IoT things on your network. I have about 100 devices on my Wi-Fi. The diagram here shows the location of my main router in the entry hall closet. That's the big pink circle. And two wireless access points, one in the kitchen and one in the workshop. I point these out because you have to plan for this when you're laying electrical wire, since those wireless access points need a hardwired Ethernet connection to the main router. I installed at least one wired Ethernet plug in each bedroom as well as in the kitchen. And am I ever glad that I did? Because originally I planned for only one wireless access point out in the workshop. When I figured out that I needed another one, fortunately there was an Ethernet plug in the kitchen, which was a good location. So even though you think you can rule the world with wireless, put Ethernet and cable into a few strategic places in your house to future-proof it. The cable in my house isn't even terminated, it's just in the walls, but it's there. LED lighting is important in a net zero home for 3 reasons. It requires a tenth of the power of incandescent and therefore is extremely cheap to operate. And the bulbs last for decades, not months. People who don't like LED lighting usually complain that it's too dim or it's all different colors. That's because they don't know how to choose appropriate light fixtures. First, you need to know about the K that indicates LED light color. The K stands for Kelvin. He was a British physicist and mathematician who developed the scale as a measure of temperature. We use it now to describe the warmness or coolness of LED light. To give you a reference point, daylight is about 5200 K. Any LED light below 2000 K is going to be a dim yellow glow like a candle. And anything above 6500 K is going to be bright blue-white. So you choose a color appropriate for the space that you're lighting. Most residential space is lit with 2700 K or 3000 K, a warm white light. A lot of office space is lit with 3100 K, even into the low 4000s. Some light fixtures now have adjustable K. The key is to look at several different lights and choose what you like, and then, and this is the important part, stick with it. Buy everything with the same Kelvin temperature and your lights will match. The other color measurement important for LED lighting is CRI, which stands for Color Rendering Index. It's a scale from 0 to 100 that measures how accurately a light source depicts the color of objects and people as compared to what they look like in natural daylight. In other words, the index helps determine whether the light bulb will make colors look true to themselves or skew them yellow, blue, or red. A high CRI provides more natural illumination. Unfiltered sunlight sets the standard at 100. So always choose a light bulb or fixture with a CRI of 90 or above. Never buy a light bulb that doesn't list its CRI, because I guarantee you it's below 80 and you're not going to be happy with it. You should also always choose a bulb or a fixture that is dimmable. It allows you to adjust brightness according to your mood or the time of day. For example, I have LED strips under the wall-hung bathroom vanities that are set to 25% to provide a little night light. Ceiling fans. I have 4, one in each bedroom and one over the piano. They are all Wi-Fi connected, so I can control them with voice or through an app. You can reverse direction for winter or summer use. I mentioned fans because, particularly with a heating system like radiant heat, where there is no blower, fans help circulate warm air and mitigate hot and cold spots. The top photo is to show you that you can fit a fan anywhere. That's the fan in the guest bedroom, stuck in a small space between the wall and a ceiling beam. And the photo on the right shows the wall in the library, where I have light switches, a remote control for the fan, and a thermostat all ganged together. The lower photo shows how a white ceiling fan just kind of disappears. Up above the fans is the roof. I elected to go with the standing seam metal roof because of its low maintenance and long life. Metal roofs are good for solar installations because there are clips for the standing seams that hold rails to mount the solar cells. A metal roof costs about twice as much as a shingle or composite roof, but it'll also outlast a non-metal roof for at least twice as long. And if you're catching rainwater for drinking, most metal roof surfaces are also NSF 61 approved. Heat pumps. MIT Technology Review says that we have finally entered the era of the heat pump. They've been around for over 175 years. The heat pump was invented in 1856 by an Austrian guy trying to draw dry salt out of marsh water. The Brits expanded from water to air later in the 19th century, and the Americans learned to take heat from the ground in the 1950s. Modern heat pumps are really efficient. A good heat pump supplies 3 to 5 units of heat for every unit of electricity used to power it. In comparison, a carbon-based heater can only produce as much heat as the energy contained in the fuel being burned. So a heat pump will always have a smaller carbon footprint than a gas boiler, even when it's plugged into an electric grid dependent on high-emitting suppliers. Heat pumps have gotten some bad press, but at least some of it comes from, yeah, you guessed it, the oil industry. In spite of that, global sales of heat pumps grew by 11% in 2022, the second consecutive year for double-digit growth. Heat pumps have the potential to cut global emissions of carbon dioxide by 500 million tons in 2030. That's as much as pulling all the cars in Europe today off the road. Some people think that heat pumps don't work well in colder climates. I think it's pretty convincing that 2/3 of the homes in Norway are heated by heat pumps. Back in the 1970s, during the oil crisis, the Norwegian government pushed people to adopt heat pumps, trained installers and maintenance people, and even after the oil crisis was over, they continued to offer incentives for heat pump use. Geothermal heat pumps are becoming more and more common. The general term for these is GSHP, or ground sourced heat pumps. That's when you run pipes deep into the earth to suck heat out of the ground. Very efficient, but a little expensive to install. Although they are coming down in price as their adoption increases. The major manufacturers of heat pumps are Daikin, which also owns Goodman, and LG, Lennox, Bosch, and Mitsubishi. I installed the smallest space pack air to water heat pump to make hot water for radiant floor heat. It's hung on the exterior wall of my garage to keep it out of the snow, and its byproducts are cold air and cold water. To make it more efficient, I have 6 zones in the house. The guest suite, the workshop, and the main living area of my house are all in separate zones. I also heat the floor of the garage because my electric car likes the temp to stay above about 50 degrees Fahrenheit. And I have separate zones for my bedroom and bath because I like a cold bedroom and a warm bathroom. Those zones are controlled by Ecobee wireless thermostats. Making your heat pump more efficient also requires good insulation. You should know what your local building department requires. Although my plans called for all blown-in insulation in the ceiling, I used a mixture of 5.5 inches of blown-in and 4 inches of roll insulation to make it a little more affordable. That still exceeds the Washington Code for joist vaulted ceilings of R38. There are some new insulation materials on the market, like Gutex fiberboard and green fiber, which is made from cellulose. Both Gutex and cotton have R values comparable to fiberglass. In the house in Oakland, I used blown-in insulation made from recycled denim. There's also aerogel tape, which you put between the wall joist and drywall to insulate from heat transfer through the wood, which is very effective, but still a little pricey. For domestic hot water, I installed a 55-gallon electric mini boiler made by HTP Everlast. 55 gallons is the new limit on water heater size in Washington state. This heater heats water above the temp that you want and mixes it with cold water when it exits the heater to the temperature you call for. It's very efficient to heat and keep hot a smaller amount of water. The heat pump on the right is the Daikin Altherma I installed in the house in Oakland 10 years ago. It supplied both domestic hot water and hot water for the radiant floors. I added this photo because this was literally the only thing you could buy in the US at the time. It was total overkill. It was designed to support a 4-apartment building. You can't even buy this model in the US now, but Daikin has just come out with a new, smaller Altherma for the US market. As I finish up, I want to point out why Lindal is so great for building net zero. First of all, their materials are responsibly sourced. Your Lindal home will be built of high quality natural materials. The Doug fir I got for the inside trim was just beautiful wood. Even the glue lamps that hold up my ceiling are pretty enough to leave exposed. There is no steel in my house, just good wood. Lindal offers beautiful designs in a range of sizes with lots of windows and high ceilings that give a spacious feel to even the smallest homes like mine. They are customizable for a very reasonable architect's fee. I built the house I wanted, the house that was perfect for me. Lindal also provides a lifetime guarantee on the integrity of its materials. They aren't in the business of building cheap spec houses with builder-grade materials. They're building homes that you can pass to the next generation with pride. These last 3 slides I included just for information, these are the products that I use in my home. I have a Google Home, so the products shown here work with Google, but most of them also work with Alexa or Siri. And if not, there are comparable products for those platforms. These infrastructure products are changing constantly. I understand from my solar installer that LG has gone out of the solar panel business, which is a shame because I think they made the best solar panels around, and I've had LG panels since 2008. But the landscape on eco infrastructure products is improving. And by the time you build your house, there will be choices that are even more efficient and cheaper. I also installed really good appliances, all Energy Star rated when possible. Hey, did you know that the Energy Star Council does not rate ovens? I found that out. Also, I installed high-end under-counter refrigerator drawers in my kitchen to keep the lines clean, and I really love not having a huge refrigerator. I put a cheap little chest freezer from Amazon in my pantry, and the arrangement has worked out really well. You don't have to have a big refrigerator. This last slide is a list of my subcontractors, which I wanted to include just to say that this was the A team. I got lucky in Kitsap County and found absolutely wonderful craftspeople to build my Lindal home. I can't say enough good things about them. And there is my home as of last July. I'm going to turn it back over to you, Christina.
Thank you so much. Wow, I've, I've now heard that presentation twice, and I've learned even more. So thank you so much for presenting. I know so many people, I'm sure, learned a lot about building an off the grid home, and just about building a home in general. It really is so wonderful that you've taken the time to educate us like this. Thank you so much. I just put back up a couple of the last slide I was on, but we do have quite a few questions that have come in here. If you have a few more moments, Laurie, and don't mind answering, I
Sure.
would love to pass some of these along. I will note too, we have recorded this, so I'm sure there's a lot that people will want to come back to. So feel free to reach out to us and we can share the recording and you can listen to it again or share it. So one question actually I had as well, but a few other people have brought up too, is we and it's come up in other webinars, is the beautiful windows that we use. So many beautiful windows and all of this light that comes in, but also the heat that can come in. I know you touched on this, but did you explore things like triple glazed windows or other things, or are you finding that the windows are kind of worth the energy?
Well, I do have shades on my windows in my bedrooms for privacy, not really to keep out the sun, but also because it's easier to sleep when the windows are covered. But the windows in the living room, I don't cover at all. And I will say that they do put out a lot of heat in the summer. I may end up putting, sun blocking shades on those windows. And I'm going to see how this summer goes. I mean, sometimes summers are warm in Washington and sometimes they're just not that warm. So, there's other strategies that you can use. One of the things that I did this last summer was I installed a ginormous market umbrella that tilts on my patio. And when I tilt it in the right direction, it actually shades the windows in the living room. So that's, you can think about other things. You can build a little a trellis outside, and my home in Oakland had a trellis on the west side for that very reason, to block sunlight during the hot part of the day. So there's a bunch of strategies. Yes, it does heat up. In the summertime, that's a bad thing. In the wintertime, it's a good thing. So, I think you have to sort of balance what you like.
Yes, thank you. And yeah, it's very dependent, of course, on your site. I know that somebody in Southeast US might be very different from someone who's up
Exactly.
in the Yukon or something like that. So
Exactly.
thank you. Yeah, definitely. Just keep in mind that you don't have to go the whole way to necessarily to triple pane or small little windows or anything like that. You can still enjoy the big window.
There are, I will say also that I've investigated, there's some solar blocking film now that's coming out that you can apply yourself, or you can have it professionally applied, which goes on the inside of the windows. It darkens the windows a little bit, but it does block a lot of the UV. So you can also look at that as a possibility.
Yeah, no. So another question that came up, and I actually wrote it down myself as well, this is verbatim. This is from Jane. She asked, "Is there anything that you would do differently now that you've lived in the house for a while?"
That's a really good question. Yes, there are a couple of things. I think I would swap my master bedroom and bathroom's position because the bathroom's on the north side of the house and the bedroom is on the southwest side of the house. And I like a cold bedroom and a warm bath, so I put them in the wrong positions. It's little things like that, but is there anything that I would do differently as far as the design goes? That's the only thing I can think of. Everything else I'm totally happy with.
I'll take that. How about this? On the other hand of that, what is something that you love more than you ever expected that you would love?
My refrigerator drawers. I love my refrigerator drawers. They're under the cabinet. They're made by True, which is a bunch of cooks, professional cooks that got together and started a company that makes high-end appliances. And they're really cool.
Yes, I've been fascinated by them too. It's definitely a different way to use your
You it,
kitchen. So
it encourages you to be efficient about your shopping and to eat everything you buy, which is always a good practice. No
yes, and you can
waste.
see everything too, right? I feel
Yeah,
like
you can
that's a
see
little bit of,
everything.
yeah. No losing the leftovers in the back of the fridge. Okay. Another good question is, how did you decide on the placement of the home on the lot and the orientation to help ensure that you were getting the best kind of solar gain or shading or solar panel gain?
It's a really good question. I actually invited A&R Solar, who did my solar, to come out for a survey of the lot. And we took measurements they have some very sophisticated tools, and we took measurements to figure out where the best direction to point things. Basically the garage, which is where there's 28 of the 38 panels are on the garage, is pointed due south with the roof sloping in that direction. So they, you know, I I placed the house in the garage in the spot where we wouldn't get shade in the afternoons. We get a little shade in the mornings, but it was in collaboration with my solar providers.
Okay, very interesting. It's good to know. Get them involved early.
Yeah.
Um, so there are a couple of questions about your floors using it was a slab on grade, correct?
Yes.
And was that is that for efficiency's sake? Are you happy with those? Are they creating any moisture issues or any
Zero.
other?
I love my concrete floors. Um, so it's actually, they're poured over sand. We buried all the infrastructure in the sand. I dug a lot of those holes. I was here every day working. So with it's sand and then 4 inches of insulation, or maybe 3.5 inches of insulation, and then the PEMEX for the radiant heat is on the PEX for the radiant heat is laid on top of that, and then the rebar. So it's 4 inches of concrete, but below that is 3.5 inches of insulation.
Yeah.
Um, I don't have any problems with moisture at all. Um, I'm not quite sure why you would if
Mhm.
you do it properly.
Yeah.
Like I said, I sealed the floors with a good concrete sealer, and then I put a low gloss wax on them. Um, but I only do it about once a year. You know,
Yep.
Otherwise it's just vacuum and mop.
Though, speaking of water, did you do anything to help conserve water on your site?
Well, I have low flow toilets and low flow showers, and I have very efficient dishwasher and washer and dryer. Um, but I use a lot of water. I have well water, and I
Mhm.
use a lot of water on my irrigation. So I guess it kind of offsets. I'm in the summertime, I do use a lot of water.
Yeah. Okay. And again, we do have this all recorded. So if there was a couple of questions about seeing this again, so absolutely happy to share all of this with you if anybody missed anything. There are a couple of questions about Lindal and working with us, what the process is like in a little bit more detail, of course, budgets and things like that. And I do encourage you to attend that webinar in the beginning or in the middle of the screen there, Elements of Modern Home Design. That is our webinar that is 100% about the process. We talk about how much it costs, how long it will take, and the different processes you can go through, like Laurie did. We have other ways of building a custom home too. So I do encourage you to attend those webinars. And I won't take up any more of Laurie's time. I do really, really appreciate all of your time that you have given us. We really can't thank you enough. And we are excited to keep answering all of these questions. I think we could be here for another hour to answer all of the questions that have come in from the couple hundred people that are on with us tonight. So thank you again for joining us, everyone out there. And thank you again, Laurie, once again. Really
My
appreciate it.
pleasure.
Have a wonderful evening, Laurie, and everybody else. Enjoy the rest of your evening. Thank you.
Thanks.
Good night.